So we're getting some AD support here from all over the place. It's really great. Thank you. Oh, getting there.
You made to get unstuck.
This is where it gets easy to remember which IETF meeting we're in. And lo and behold, the slides I prepared earlier. Now, this is super good. So we're about to start the Tsvwg meeting. There's a big box here. You have to walk over this way, so mind your step. Otherwise, stand on the pink cross. We can do up and down, can't we? Oh, thank you. See, we have great support here as well. Thank you ever so much. Okay, so welcome everybody. This is Tsvwg. It's the second meeting, Tuesday's meeting. And we start with just a quick review of the agenda. This is our agenda. You've already seen the note well. The note well is in the slide deck. Remember, everything in this meeting is covered by the note well. Read it if you haven't done so. Our agenda has 2 slots. Firstly, working group drafts, where we have 3 drafts scheduled for today. And then a couple of individual drafts. The individual drafts are looking at 2 topics. Where does HTTP 2 as a transport fit into the IETF? Very big question. It could be here, or it may not be, but surely we should talk about this draft, and we'd love to get feedback on that today. SCTP retransmit bit is one more bit in the SCTP header, and that will be presented as the final presentation for this session. So we start with SCTP and end with SCTP. Michael.
5.1 or 5.1a?
5.1. Oh.
Okay, this is about revision of RFC 4960 bis, RFC 4960, which is the base spec of SCTP. So RFC 4960 was way back written in XML, went to the RFC editor, was converted to NROF, and published. So in doing a BIS document, we wanted to submit the RFC almost as is, as an internet draft, and then you can follow with a diff tool the changes. So this was happened. The simple thing was to submit version 00, which was basically the NROF sources tuned up a bit, making an internet draft out of an RFC, change the legal stuff and submit it. And then the stuff was rewritten completely in XML to match the formatting, which worked okay-ish, except for one section which is dealing with the abstract API, and it had a strange formatting, which I couldn't teach XML to do so, but that section is not that critical because it's an informational only. So the text should be there in a different formatting, and the rest you can check with a with the diff tool. What's in work in progress is getting 50 changes applied to the XML sources, and that will be version 02. Basically incorporating all the stuff from the errata RFC. That we have to-dos then. Basically, updating the references is something we didn't do with the errata document. So some of the RFCs we are referencing have been updated, so we have to update the references. That should be an editorial thing. And in the errata document, we made sure that all the new text doesn't have must, should, and so on in non-capital letters. So either use different words or use them in capital letters. And we have to go through the document to make sure that this is consistent in the 03 version. And then we can think about layout improvements or not. So taking the tweaks out of the XML stuff, which made it look like RFC 4960 or not. But basically that's it. So the plan is to do the discussion on the musts and shoulds this week, submit the stuff, and then it can stay around for a while for people reading it and catching minor issues. We are not aware of any technical changes, so that should right now work out. Any questions regarding that?
Sorry about the floor. Just a chair question, to be clear, the next rev will...
The next rev will be 02.
Yeah, which is the full with the erratas.
Correct.
Yes. And so that should be a fairly boring thing because it's the same as the document we have, except it just merges two of them together effectively.
Yeah, not as boring as converting nref to XML.
Fine. But then maybe there's a bit more interest when we get to the version 3 and then we do the clarification of things that were maybe seemed clear at the time, but maybe now in retrospect could be made slightly clearer without changing their intent. Is that the idea?
Exactly, yeah. And you can use the diff tool to see the differences.
There is, of course, this is, of course, a new working group document. So if we do find things which are important to fix, then it is still open for people to send those fixes in and contribute to this document. It's not just an editorial pass. So
yep.
When we get to stage 3, I'm expecting more people in the working group to add comments and start discussing this.
Exactly.
Mira.
Mia Kulevin, a little bit of provoking question. Will this obsolete the errata document?
Will this lead to what?
Obsolete? No.
No.
It updates 4960, but the error
replaces.
Replaces or obsoletes 4960. Yes. The other one is an informational document which stays around documenting the differences.
Okay, the 4960 bis will disappear. As an active, useful document, because this will incorporate everything in it. 4960 will disappear.
Can you repeat what you said?
Yeah. Okay, that was a great clarification.
Okay, we're having too much fun with process issues around RFC status. So what should happen is that, I mean, and as Randy suggests, if we can get it done fast enough, this will be 8960, which would be a very nice number. That will become the new standards track reference for SCTP. So as part of that, it's pretty clearly got to obsolete 4960. What we do with the errata RFC, I think, is up to us. As Michael said, it was published as informational. We could choose to obsolete it or not.
I would suggest to do the same what we did with 4460 or whatever we had we had the same document for the differences between 2960 and 4960.
Just propose something later. That was not the point of any of my questions. I didn't have enough coffee to ask the correct question. The correct question was, if the changes are minor, do we propose to perhaps take this document along the standards track up from proposed standard?
Yes.
This is something that we have to track as a working group as we go forward.
And that decision can be made up to the point at which we submit to the IESG and possibly even afterwards. But I concur that advancing this from proposed standard along the standards track could be a very good thing to do.
Okay, then I think we are done. We're done with that document.
Next slide, 51A.
Oh, can I do next slide? No, I can't.
51A.
A different PDF.
Yeah, I'm sorry. Next one. Yep. Okay. There we go.
Perfect. This is about NAT support. It's describing how you can a way to do NAT for HTTP. And version 12 was considered finished by the authors. Gori so we said we are done. Gori looked at it and did a review and provided substantial suggestions for editorial changes, like moving things around. But this is editorial only. And Maxim provided editorial things, but also technical comments based on a Linux implementation, I think. And this has to be integrated. Some of the editorial stuff is, well, move text around, and we need to figure out how to do this. The technical thing basically was like, some of this was splitting up different functionalities of the document. So we do single homing, multi-homing, and so on.
Maxim, proszę. There was one technical issue that I don't like how it described in the draft today. So you propose to keep the track of all associations in that device, and in case there are many associations, that will lead to many hash entries. And what we observed today, that in case of many associations, that will lead to issues, and basically it works slowly. And I made a proposal how to avoid tracking of each association and track only HTTP instances behind of the NAT device. So
I have a hard time to understand you. Can you be a bit louder? You didn't want to put an entry per association,
yes.
But
what I think I heard was that the text currently requires you to track all the association state, whether you need
yes,
it or
exactly.
not, and some careful attention to detail and perhaps aging things out, which all other NATs do anyhow, might reduce the amount of state that the doc requires you to carry to what implementations are likely to do.
what state is tracked which is not needed?
Well, in my comments, I made one suggestion how to avoid tracking all these associations, and I want you to look at it, and
okay.
We can discuss. We can think how to avoid that amount of entries in the hash.
I think you need an entry per association, but
yeah, we can discuss.
okay. Okay, so this has to go in. This might be technical changes, and we'll be ready by the next IETF.
When, Michael? Next IETF?
Nick, ready? We will have a revision with Maxim being happy and you being happy by the next IETF.
Excellent. Thank you. It'd be good to get that going.
Right, and expectation is that we'll send that revision almost directly to Rick last call when it appears. So the next IETF, we're mostly concentrating on the BIS draft.
Okay.
Okay. All right. So we're going to do its thing again. All right. Okay. Hang on. Whoops. That was what I wanted to do. It hit the wrong slide. I need. Okay. PLPMTUD.
Hi, it's Gary Fairhurst as an individual, and much louder as an individual. This is an exciting document, but a very boring presentation. You've probably got the longest acronym. We intend to keep that prize for DPLPMTUD. The authors have been working on the draft, and we've improved the description of ICMP. ICMP issues are more clearly defined. This is a tricky thing to get right, and I think the text is now more or less there. Please read it if you're concerned. We also described the path to big processing part of the algorithm, and I think that's kind of ready as well. So what's the main contribution? Are you ready? It's a simpler diagram. It's the same state machine, so I said it was a boring talk, I'm sorry it is, but the diagram is much, much simpler because Michael redrew it for us with help from our new co-author, so you might have spotted the author list has increased the editor list. This is the state diagram. You can even ignore the arrow state if you want to be really simple, because that's to deal with strange things, and it does make it look simpler, and I'm trying to say please read it. We've done some work to play with this, to work with the text, to test it, to help feed into Quick. Basically, we're working on trying to get more experience of using this and making sure that it's absolutely correct before we publish it as RFC. There's lots of gotchas in this space about how to deal with loss, reordering, how to deal with rogue things on the path that might send you something to annoy you, etc. So these are things that we want to get right, and we will provide as much input as we can for the next IETF, where we may be ready for a working group last call, which would be cool because I think Quick would like to reference this, and that's their timescale as well. Any questions? Then I'll show you the exciting bit. The diagram's easier to read. Next slide, please. I'll do Joe as well.
Okay. Ready? You're gonna challenge Joe. Okay.
Maybe we have a question on the PLPMTUD while you're getting ready.
Martin Duke from F5. Has anyone implemented that?
Tom's tried. I thought that would get into the mic.
Tom Jones. So I think as it stands, we've had 5 or 6 implementations over the lifetime of the draft. We haven't had an implementation since we changed the diagram, but if you look at the diagram, it's like we pulled a T-shirt through its neck hole. And so it's the same machine, it's just different. So, yeah.
So the answer is the answer is yes. Yes has been implemented. Even implementation doesn't even if the comments implementation don't exactly match the new and improved diagram.
Okay, so in what context was that done? Or was it a quick implementation, or was it some other UDP-ish?
We have 3 implementations with custom UDP protocols, an implementation with UDP options, and an implementation on MozQuick in July. That gives you a time frame for when.
Praveen, question less about this draft and Quick referencing it. So when Quick references this, is it going to be recommended as the way to do PMTUD for Quick?
It is recommended as the way to do PLPMTUD, and the current Quick text also says you can do PMTUD if you can work out how to do that for UDP, which could be challenging, but that's what the current text says. We work with the Quick contribution text, so it does align with what we say here. Quick doesn't mandate all this stuff because this stuff's not kind of published as an RFC. Maybe in the next version of Quick we can be stronger and we have more experience.
Yeah, I mean, I think the big difference in Quick versus pure UDP is that Quick is authenticated end-to-end. And so that makes the security consideration easier to resolve, because, I mean, if your peer says, I did receive this packet that contained 425 bytes, then you know that that's true. And that creates a difference in a different consideration.
It's a feedback mechanism, which is actually a stronger feedback mechanism than the other feedback mechanisms we have. The algorithm can be more or less the same, because it doesn't matter what you're sending, as long as the transport can tag it, as long as the transport understands that it's not real data. The algorithm can be the same with Quick, but the feedback is encrypted, which makes the feedback authenticated, which is definitely good.
I did implement a version of that in my implementation of Quick. The one thing that would be very, very useful is that when you do an end-to-end, basically, implementation, you are doing a search.
Yes.
And when you are doing a search, it's nice to have some kind of Bayesian logic based on what you know about the network.
Yes.
And so what would be very helpful for those implementation is open statistics about what are the commonly found PMTUs.
I agree. I actually have a research proposal in this space to do some big surveying and try and work out some great algorithms. At the moment, the algorithms are purely heuristics, but I think we can get that data out. So if other people want to help, I'd really love that.
Because what I found myself writing in the Pico Quick implementation is a cost-benefit analysis. Does it make sense to send another probe for that particular value based on what I will do on the rest of the connection? Like if I know that the rest of the connection only has to send 2.5 kilobytes, well, maybe not.
Yeah.
But the answer to that question is dependent on what is the likelihood that that next probe will succeed. And that is based on knowing the statistics over the internet, in fact.
Yep, and also perhaps information about paths, because we don't know whether we have previous statistics, whether they will apply again. There are a few things in this space which would be really good to get ground truth on before we get an algorithm. That's the main reason why the current draft doesn't have an algorithm in, because I think this is currently a good area of research, but I think we can get there quickly.
Okay, and let me just yet another double entendre. Check the time scale on which this draft needs to move in order to avoid having the Quick work group descend on us en masse. My understanding.
If you're going to ask me officially, it's July. I can talk to you afterwards, having talked to the Quick chairs, but they're all aware of this dependency, and I think we are aware of their requirements.
Okay, so this would need to move around the time. This needs to move around the time of the Montreal IETF. Should we be looking to last call it before Montreal or after?
I think the initial customer for this is Quick. I'd rather speak to the Quick chairs about the real timelines, because they know the dependency and we need to meet their dependency.
Okay, let's do that offline, because I think we've got a lot of drafts potentially headed for working group last call. We'll talk to the Quick chairs offline and figure out when to do that to this one. Okay, make a note of that. No problem. That makes sense.
Okay. So in the next presentation, I shall attempt to represent the document editor for the UDP options draft. I will do my best to do what Joe has asked to present to the working group. Joe Touch is the editor of the UDP options draft. This has been around for some time. It changes each IETF, and there's been a lot of discussion on the list prior to this IETF, and Joe's made an update that includes some of the responses to this, but not all. Recent changes, he believes, incorporated the CCO work that was done. That was presented by Tom at the last IETF, and we now think that all those changes are incorporated in this version of the draft, so that should improve the traversal of middle boxes and the checksum treatment. Rules have been extended for dealing with options and how to extend them. And the basic rules that Joe puts forward are always drop options if the OCS fails, but still deliver the body. And the receiver decides whether to require any option. There was discussion on the mailing list about whether we should always require CCO. Joe's position is that the receiver decides whether the CCO option is required to be present. Current internet operability probably means you want that. In general, Joe puts forward that any option is decided by the sender. They decide what to include, the receivers decide what to require. There's a possibility of adding soft state to this so that you can tell the receiver that once it's got an option, it would always need that option to carry on. There's issues with that, where somebody injects a packet with the option, so that needs to be thought about. But the overriding design of the UDP option space is a design which will be consistent with legacy applications. So if the legacy stack does something like strip all the options, then the behavior should be the same as UDP. Joe wanted to include a slide to say that these are UDP options. It's not an encapsulation method. It's not designed as a way in itself of providing transport of other things other than the UDP payload. So they are things that are added to the body. And options themselves should be discrete items. They don't depend on one another, except perhaps for the OCS, which is required to validate the whole packet. Joe says you cannot declare the order that options occur, except when they are fundamental to the processing of the option. Then we have the more detailed slide about the more detailed problems or questions or debates. This slide refers to the use of fragmentation with the light option of UDP options. And this is an area that's been discussed on the list. There's various views about how we should do fragmentation on light, and Joe puts forward the view that the checksum is 0 is allowed, and if you must have the checksum set to 0 to allow traversal of middle boxes that misbehave. He is keen that we look at reassembly, and I don't know really what else to say. If you're really following this, please read the slide in detail. The text is too small for you to perhaps read here, but please read this. Joe's not present, so the feedback mechanism to Joe is comments on the slides, comments on the presentation, all on the list. And Joe promises to respond actively to anybody who brings this up on the list to continue the debate. He just physically can't be here. There was discussion whether we should include a require or ignore flag in options, such that we have at the IP layer. So when we negotiate extension headers and things in network layer protocols, we have to know whether we require or don't require these options because they are processed entirely with the packet without any transport context. Joe's argument is that we don't need this because these are simply options to the transport. So we don't need these flags, and a receiver is built to expect options or is built to ignore options, and these are the only possibilities. Joe was asked about the surplus area after the end of the UDP options. The way UDP options work is it uses the length of the packet after the payload to insert the options. Could you have a space after the options, which is yet more space, which could be used for something else. And it's a good question. I mean, does the option have to fill the rest of the packet or not? Well, I guess probably. I agree with Joe. We haven't said they have to fill all the rest, so there could be something else afterwards in future. How that works? Well, all bets are off as to how you know what is in there. Given the previous presentation, you probably need another checksum compensation option inserted in that use of the surplus area as well. That's for another IETF. I believe it's for another document if anyone ever wants to write that. This isn't something that Joe wants to take forward. And if I would sit over there with my chair hat on, I would say, please don't bring this forward. Let's just check that things are possible and bring that forward at some future time. There's other possibilities here. There's many ways in which we can design this. This is partly a design activity as well as a protocol development. So we could have a fixed header, and we could require different things. At some stage, the working group has to decide, and Joe's draft represents what he thinks is the right way forward. Of course, please discuss on this. There's changes because in the effort to make this available for this IETF, a few things still remain on the pending list. So there's typos in various places. There's a list of current typos. They'll be fixed in a new rev soon. The middle box traversal section needs to be updated now to reflect that the OCS works and how that doesn't work if you in future decide to put something in this surplus area. And as ever, light and fragmentation remains a point of discussion. Should we have a cookie option? Potentially, this is an option. If we understood the need for it and somebody wanted to come forward with a proposal, I guess this could be included. It could be a separate draft. It could be incorporated in this draft if the reason for it was clear. Clearly, it's possible to send a cookie as an option. Tom, you contributed on the list. Can you?
What is a cookie option? I don't remember that one.
I think a cookie option, if I remember right myself, is the idea of just sending an opaque value as an option and getting it reflected from the other end. So that you can then verify that this packet hasn't been inserted by an off-path attacker or whatever you want to do, or even set up some soft state. Yeah. So Tom said okay, by the way, just for the record. So I think we got that. Any other questions, though?
Could you take off your virtual Joe hat, put your chair hat back on? Let's quickly talk about timing of this draft. My sense from the state of list discussion and the number of topics on the slides is we need another IETF cycle of soak time before we working group last call this. So I just heard Gory say yes. So I'm proposing to move the milestone for this from May to September of this year.
I'll respond to that and then with my chair hat on. At the moment, there's a small dependency of this with the UDP, PLP, MTUD, but we should discuss how we deal with that because I think being a normative reference to quick is important, and this is another way of transporting it. So.
After all the work we did to escape the WebRTC cluster, here we go again. Okay,
yeah, just bringing this up, as in sometime we're going to have to cut development on this if we're going to have it as a mechanism. But there are ways out of this as well, because the things we need in DPLP MTUD could be exported to this draft, and we could simply refer to it as another way of doing it.
And what we can
we will address that issue.
We could also package this with PLP MTUD, which is currently we currently think is shortly after Montreal. So the plan's not broken yet.
Okay, thank you. No, Tom.
Okay, we will talk to the quick chairs offline about what we're going to do here.
Tom Herbert. So I do agree there are a number of issues and they are coming up on the list, so you can go through that. But I'd like to point out two of them in particular. So one is the idea of the surplus area having other uses.
Yes.
I look back, I cannot find any reference to the surplus area in any RFC. So I do not believe IETF ever reserved that area, which means it may be in use by somebody else or it may have garbage bits. I cannot deploy this on the internet without a way to disambiguate those other uses from this use. So I think that's a pretty clear requirement. The other thing, and I did mention this on the...
Okay, wait a minute. Let's go for that one first.
Okay.
Would the incorporation of the OCS checksum over the UDP options area serve as a way of rejecting garbage?
Yes, that's why I advocate a fixed header in the surplus area. So there's a draft on that would effectively give you that.
But also, including the OCS option would give you the same protection if it was always required to be present.
Having a fixed checksum makes sense from many viewpoints. There's also a sub-issue. So one of the ideas was always force UDP checksum equals 0. Cannot do that in IPv6, right? Because the UDP checksum is required. So we have a big hole there. I don't think that 6936 is going to be easily twisted to allow this use case for 0.
No.
So that's really not an option to say we're forcing UDP checksum equals 0. And besides, that's a bad idea because we're losing UDP checksum. There is another side issue. If you're using Frag and Light and you move the UDP payload into the surplus area, that is no longer covered by the UDP checksum. So now we have a hole there. So you really need that checksum regardless in the UDP and in the surplus area for several reasons.
I think we need the CCO checksum anyway to get through nuts.
Okay.
And it's a UDP mechanism, so we expect to go through nuts.
So we can revive that discussion. I think that the biggest issue for me, though, is this concept of option negotiation.
Mm-hmm.
This is referenced in the draft, and there's a concept of soft state. This is just a big question mark for me. I don't know what this is. If I was implementing this, I would have no idea how to do a robust option negotiation, nor how to make it interoperable. So either this needs to be fully qualified in normative language, or it should somehow be taken out. But if it's taken out, then some of the assumptions, like what to do with unknown options, really should be changing. So this is trying to straddle the world between stateless options like we have in IPv6 that are kind of idempotent versus TCP options which are completely negotiated. So somehow it's like there's an in-between here, but I'm not clear what that in-between is, or even if it's possible to have something that's robust in between those two.
I think, let me not answer this as a presenter, but answer this as a chair. I think we should be clear on what that means. I have ideas about what Tom means in this space, and I have ideas of what Joe has said in this space, but the draft text needs to reflect that in a way that other people understand this.
Christian Wittemar. I have a concern about using UDP options in general when using encrypted transports. Because, I mean, take the example of Quick. There's absolutely zero chance that Quick will consider anything that is outside of the encryption envelope.
I'm not sure why Quick would want to use UDP options to negotiate something between the endpoints, because Quick already has mechanisms for doing this.
Yeah, and so basically we have to be very clear about the applicability statement there. I think for anything encrypted is probably not applicable. Anything in which the application does end-to-end PMTU discovery, that's probably not applicable either. Because if you do end-to-end PMTU discovery, you are very likely to use some kind of don't fragment option, in which case there is zero space at the end of the packet.
Yeah, not sure I understand that last one.
Well, the reason UDP-based application do end-to-end, do MTU discovery is because they don't want fragmentation.
Which flavor of MTU discovery? So, do you mean the path MTU discovery at network layer, or the
end-to-end?
Okay, so you mean something like DPLP MTUD type algorithm?
Yeah.
Okay, fine, yeah.
So you do that to find the MTU.
Yes.
And then once you have found the MTU, what you typically do is that you are going to send packets that are exactly that length and put the don't fragment bit on them.
I don't know whether you would, because now you're combining the PMTUD semantics with the PLPMTUD semantics, which I'm not sure is a good combination. I think you can do this, but you end up with two algorithms creating two control loops.
So I think the Christian's point.
And I think you could have a third control loop, actually, because if you use UDP options with Quick and PathMTU discovery with DF underneath, you'd have three ways of doing PathMTU discovery at the same time, which is never good and probably isn't good for security, and certainly isn't good for performance.
So, okay.
Don't do it more than once.
But let us record that I'm very concerned with the applicability of this draft in practical deployment scenarios.
Okay.
And Christian, I think I heard something else in your comments, which is that we have to be careful about level of reliance on these because the application can arrange for there to be no space in the UDP packet to put anything.
Well, just the application adds the option. So yes, sure, but we need to think this through. Anyway, we need to think the interactions through.
Need to be careful here, particularly if the application is structured as stuff that does useful work and a shim layer that uses options to get the network to behave. You can get back into the corner Christian's worried about.
Yep, tunnel. Mira.
So I agree on the level that you don't want to use UDP options with Quick, right?
Yep.
But first of all, it's both under control of the endpoint. So if you shoot yourself in the foot, it's like your control. And then I think it doesn't matter. It's not a concern for this document. This is like an extension to UDP. If you don't want to use UDP options with Quick, that's a recommendation you should give in the Quick document.
That would be fine with me. My co-chair is typing. I could take any more questions, otherwise I can stop pretending to be Joe. Okay. The one thing I would request is that we try and get Joel to publish frequent updates so that we capture what's discussed on the list in the draft.
Right, and the action item coming to the chairs out of this is both this draft and PLPMTUD drafts. We need to talk to the Quick chairs and make sure that we have compatible plans for when things move.
I'll take that as an action on myself. Next slide.
Tommy, I think you're next. Eric, okay. Sorry. All right. Okay. So, how are we doing on time? Do what you need to do. We have about 20 minutes. We have one more draft we'd like to fit in.
Okay, we can do like 10.
That would be excellent. 10, perfect. 10 plus 5, and we'll have 5 to clean this.
Excellent. All right. I'm Eric Kinnear. Tommy and I have a draft out for using HTTP2 as a transport, which we've discussed a little bit previously in HTTP Biz, but we wanted to bring here as well because a lot of it is using HTTP2, but as a transport, and so a lot of the kind of transport properties of that come into play. So I'm going to kind of bump briefly through the how we do it and what we're doing so that we can talk a little bit more at the end. I've got some questions of, how much do we address different topics and different potential issues, and kind of how do those apply. So in terms of motivation, we're looking to have a generic transport for secure arbitrary byte streams. And we want to do that over multiplex streams on a single underlying transport connection. There's a number of ways to do that. Quick's going to be one of the future ways to do that, but we also want to be able to do that over TLS and TCP in a way that looks like something that actually gets across the internet. Some of the benefits we get from that are the low setup costs for new streams. We want to have a single congestion and recovery context. So if we know that we're sending multiple streams worth of data to the same peer, if we can share a congestion context, then we are effectively using that link to its best ability and can use all the information about that data actually getting there. We also want to be able to use this for peer-to-peer communication, and this is where we start to do things that aren't as traditional in HTTP land, where we want the server to be able to open a stream back to the client. So once I've got this tunnel established, I want to be able to make a new bidirectional byte stream in either direction and have either side initiate that, and then send my data across it. One of the example use cases for this is remote IPC or other associated things. And we want to share this underlying transport with existing infrastructure if possible. So this is kind of a nice to have, but it is nice to have a situation where you already have an H2 connection to some server because you've made a request to it or something like that, and you're sending normal HTTP2 streams with requests and responses, and at the same time I'd like a byte stream to that server to send other data with its own framing or its own protocol. I'd like to have that share the same underlying transport connection. A little bit on why we're trying to do this within HTTP2. Effectively, HTTP2 gives us a really nice framing layer that has a lot of transport features that we're looking for. We have a configuration exchange, which leads us to a very nice extension mechanism, which is how we're doing this in the first place. It gives us the stream multiplexing. It gives us the stream state machine that mirrors other byte stream like TCP state machines fairly well. It's pretty easy to map that one on top of the other. We get that shared congestion control. We get that shared recovery state. We get flow control, so we can have per stream back pressure. We get stream relationships and priorities, which is something that you don't actually get if you just open up a bunch of TCP connections or TLS connections. And it's also kind of nice because it traverses the internet pretty darn well at this point. A lot of the properties that we're getting here in terms of the shared congestion control and the shared recovery state are actually coming from the fact that H2 is going over TLS and TCP. So it's not that this is purely something that HTTP2 is giving us. This is the entire set of that connection and the underlying transport that it's already using. We'd like to be able to reuse for additional streams going to the same place. Very briefly, just the mechanism by which we do this, which is not necessarily the thing we're looking to discuss the most right now. And there's been several proposals on how to do this. Many of them are equally good. Right now, there's a connect method in HTTP that lets you establish a new connection from the server to somewhere else and tunnel your bytes through it on a particular H2 stream. And for WebSockets, there's an extended connect handshake defined that allows you to not just use connect to tunnel through the guy you're talking to someone else, but also establish a new stream directly to that person. This is nice because it also allows us to potentially proxy UDP if we stick some framing on there. Some of the reasons to use connect over the alternate proposals are you can always stick extra stuff in the HTTP headers for additional negotiation of what the next protocol is going to be, which is one of the discussions that's come up so far is how do you know once you've got this nice byte stream to the other side, what you're going to be talking on it and make sure that everybody's coordinating properly. And it also can coexist really nicely with existing HTTP request and response streams. So you can be making requests and reuse that same connection that you've already got there. You've already opened up the congestion window. You're already having a very nice, effective conversation with somebody. Let's reuse that without having to handshake all over again as if we're somebody new. In order to do this, basically the extended connect handshake for WebSockets defines a protocol pseudo header, which currently has one value WebSocket. And we'd effectively define two new values, one for byte stream and one for datagram. Byte stream maps to, hey, this is a byte stream, and I'm going to send you a stream of bytes. Datagram maps to, hey, I'd like to send you delineated messages, and I'm going to use some framing on that. The actual wire format of the framing is not yet in the draft, and that's come up on the list as well, so we can byte shed the precise format that gets used there at some other day. But effectively, this allows you to say, hey, I'm sending you messages that I'd like to come out delineated on the other side, or I'm sending you a stream of bytes, which you can feel free to repackage however you choose, as long as it maintains its order. So that so far, just by adding the two new protocol values, gets us most of what we're looking for, with the exception of this piece for peer-to-peer communication, because right now the server is unable to send that back to a client. And this is, like I said, useful for remote IPC if you're trying to talk between two different peers. It also comes in a little bit handy for QUIC. So QUIC is interesting because unlike HTTP2, QUIC splits out the transport layer from the HTTP mapping on top of it. And this effectively brings that concept back into HTTP2. So if I'm using HTTP3 and that's mapped on top of QUIC and I discover that I can't use quick on some network or it's been disabled, I need something to fall back to. So I fall back to HTTP2 mapped on top of TLS and TCP. If I'm just using quick transport as a transport protocol without the HTTP mapping on top of it, and I discover that I can't use that because it's been disabled, I need something to fall back to. And so if I'm just doing quick transport, this effectively provides you something you can fall back to that's going over TLS and TCP and is going to be the analogous fallback as it were from HTTP3 to HTTP2. So all those nice transport features that we get from HTTP2 are also transport features provided by quick transport. TLS and TCP come together to form what's missing from quick transport, which is the reliability and the congestion control and all of the rest of that. So if you put those together, you effectively have a nicely mappable transformation from quick transport back to HTTP2 transport. So we take our existing solution, which is defining the additional protocol values for bytestream and datagram, and we define a new setting that allows us to negotiate this as a further extension on top of HTTP2 that says, yes, I'm willing to process these frames in a direction that other people would be very confused by, and allow the server to send me a connect request saying, hey, I'd like to open a stream to you. And we've gotten a couple people have spoken up already with interesting use cases for this that we had not yet considered, but that are all equally great and where this comes in super handy. So effectively what we're trying to do here to kind of recap why we actually care from a transport perspective is if we can share multiple connections and byte streams to the server, if all of that can go over a single underlying transport, that helps us out a lot. It also helps if we need to be proxying UDP traffic, which is one of the things that's come up through some of the Helium and Hint stuff that Lucas has been doing. As we start trying to make more room for that, this gives you a framing layer and this gives you a way to traverse the bits of the network where you previously couldn't. And this also gives you kind of built-in security, the same way that you get with quick transport, and the same set of low-cost setup for new streams and all the benefits that come with already having a relationship established with the server and existing communication flowing between you and them. The bidirectional part of the connect handshake lets you do the same thing for peer-to-peer and pulls in the quick use case, which I think is about to become much more significant. So the big questions that we have here, and the reason why we're trying to talk about this so much from a transport perspective is as you start to do this, some of your assumptions about what you're provided by the network change. And the biggest and most obvious ones here are things like now you have head of line blocking in a place where quick transport previously didn't. You now have some very interesting questions about what do you do with connection limits on flow control and how do you manage the credits for balancing what might be a reasonable kind of credit for a request or a response where you're expecting fairly small data to go in one direction and larger data to go in the other, where suddenly now you're sending a differently defined protocol that may have a completely different pattern of usage of the transport, and can those coexist within the same context? I have an additional items bullet here as there are probably other things that come up. I know we have a draft that we talked about previously, I think in Montreal, about encapsulating other things within TCP, and that hit upon some of the same, now you're multiplexing multiple flows over a single underlying flow. Here are some of the concerns. So this may be somewhat of an extension of that conversation. We also had a bit of a question of how much do we want to make this a little bit more generic to discuss how this applies to many other multiplex transports like SCTP, et cetera. How much do you reference that, include it, talk about it? As a brief kind of straw man proposal for how you handle this in an interaction sense, the current thinking is that you would both allow introspection or discoverability of what happened. So if I say, please get me a connection to this other place, I would like a new stream there, and I was expecting it to be over quick transport, but now all of a sudden it's over H2 transport, I suddenly have head of line blocking, and I may want to adjust my behavior or the amount that I'm balancing fairly what I send on different streams, et cetera, et cetera. So you need to be able to say, hey, now that I've connected, what happened? What are the properties of the transport that I'm going over now? And then there's an entire other subclass of people who are very likely to want a stricter mode where they say prohibit this. And basically, I cannot handle having head of line blocking. My application, I would rather not connect than connect and experience some of those caveats. So that's currently kind of the bimodal approach that we're taking, but that's where the questions and the ask for a discussion comes from.
Can I ask the first question? Yes. What's the name of the draft?
The name of the draft? As in where does it go?
Yeah, we didn't get the draft name of the title.
So it is using HTTP2 as a transport for arbitrary byte streams, which is currently draft Kinnear HTTP biz HTTP2 transport -01.
Draft Kinnear. Yes. Okay.
David Black from the floor. So we have an additional item for you. The first approximation, what I've got is yet another way of tunneling UDP over something, which means you need to put on your what goes wrong with tunnels hat and framing.
Yes.
And the first thing that goes wrong is MTU. So please think through MTU from the start. If you're running, basically you're running UDP over what looks like a very funky link. That link has an MTU. See the anti-area tunnels drafts for a lot of useful thinking. Not all of which will be applicable because there's an awful lot going on in the stack under you. This is particularly important because if you make this work, sooner or later somebody's going to figure out how to gateway this into actual UDP over IP from the far side.
Yes, that is a very good point. We'll make sure to pull that in.
Yeah, Spencer Dawkins is the responsible area director for this working group for about 45 more minutes. So I think I just want to follow along what David said, and I think you're definitely pushing on this in interesting ways, and I think you're doing at least some of that conversation in the right place here. Thank you for coming here and bringing it. I think David has a good idea, but understated the possibility for this stuff to be stacked up in new and exciting ways with other stuff. I'm waiting for somebody to be running MPLS over UDP over this, and that will be I'm getting challenge accepted over here to my left. So like I say, just remember, you're looking at general purpose protocols, and you really don't have a lot of control over where people might use them. So you really need to be thinking about what the worst thing that could happen in all of our collective imaginations as you're doing that.
Yes, and especially as we look at other references to pull in and some of the existing work, there is, I think you mentioned at least one, and there's a couple more that people have pointed out to us that are really good to pull in. So we should make sure that we at least reference them and hopefully pull some blurb of text to say, hey, like, if you think you're going to do anything in this area, make sure you thought about this, and if that sounds scary to you, go read that.
So, Tommy Polly, as a author, just a question on process stuff, because I know we're quite out of time here. When we had originally presented this to HTTP BIS, they said, hey, cool that you're doing this. Please take it over to transport to see what they think. And the AD, Spencer here, agreed. So we've done that here. I think there's a lot of good advice that you're bringing up, and I think these are things that would need to be incorporated into the document. I guess the question is, does this go back? So we have an agenda item to, on Thursday, talk back to HTTP BIS to say, what did transport think? And so we'll summarize some of these things. What do we want to do as far as moving the document forward? Is this something that we just do in HTTP and come back here to say, please review our transport bits, or the other way around?
Yeah, well, I would like to go on this one because I don't want to answer the question, but can I give a hint at the answer to the question? If it was to come here, we would want to talk to the interior people about tunnels and the usage they have of this, but we would like to do the scary stuff about how the transport functions work. It sounds like that's the place where the scariness is. But the clue for doing this, it looks like it's in apps. So it's going to fit between all of these things. I have no problem currently, as a working group chair, in giving you time here to discuss this. And I think this place is the right place to discuss some of these issues. Where your home is, I need to speak to somebody with a relevant coloured dot, a yellow dot, to figure out who actually wants to take a home of it. We've worked with documents that go across areas, and I'm sure that's fine. I do think that the transport properties and the transport features have to be dealt with first, so I really would encourage you to come back here and work on those here, irrespective of where the final working group is. Spencer's at the mic, and he's still got the yellow dot at this moment.
It's fading. So Spencer Dawkins again, and I mean, seriously, we're pretty good at stuff that fits in one area, and cross-area stuff is a challenge, but it's one of the things that separates the IETF from a lot of other SDOs and a lot of other technical organizations. So making this work well will be a challenge. I hate to be the one to echo what has been said before, but it will be a challenge. But it's really important, and I think this was actually one of the better places that you could take a shot at that. So, like I say, thank you for bringing it here, and good luck, and I will help as much as I can help without dots.
And Rodrigo. I was just going to say, it's turning into a tunnel, therefore ECN considerations and nested congestion controls. Yay.
Oh, yeah. And what I was going to say was something along the lines of what both Spencer and Gloria said, which is that, so first of all, my reaction is a lot of the draft content is going to belong in HTTP BIS because it's going to be highly specific to exactly how HTTP2 is being used to carry UDP. Nonetheless, there are crucial technical issues here. This does need to be spanned across both working groups, and the incoming AD might even want to assign one of us or someone from this community as designated victim to make sure the transport issues get dealt with appropriately in this draft.
One of the things that's interesting is we do have that other document about some of the tunneling and the other concerns there. So it is one possible way to take this is to stick the HTTP specific, we're updating a registry that already exists to all that stuff in HTTP biz, and have that be very tightly coupled to have a lot of the considerations in there, just because you don't want people to miss it if they read the main document, but have the other one that's here that is much more in depth on the tunneling considerations.
I'd actually prefer one doc.
That's totally fine too.
Because the clue that otherwise the person who's not clued into what we did reads the summary doc and doesn't understand where the bodies are buried.
Reading lists are hard to make progress on. Yes.
But it's all right to write multiple drafts, as long as you recognize that there's one document at the end. If you want to get something captured, you write a short draft. We will go and talk to the authors and the ADs and help.
Thank you.
We're out of time, but do we want to try to get one slide, maybe two up on what the SCTP RTX bit is? Let's do that quickly.
So this is a new individual topic, so I guess heads up, this is something to look at.
Yeah, exactly. So, so this is a draft where I try to solve the problem where SCTP cannot distinguish if SAC acknowledges original data or retransmitted data. And the idea is to just reserve one bit in data and SAC chunks. Since both ends are impacted, it requires negotiation during association establishment. And there are two basic rules. If successfully negotiated, then SCTP should set the R bit every time it retransmits data or I data. And when data or I data with R bit is received, SCTP must immediately respond by SAC with R bit set. So from that SAC, when SAC is received back, we can distinguish if SAC doesn't include R bit, it means original data is acknowledged. If it includes R bit, that is retransmitted one. I mean, it's straightforward for implementation. There are a couple of challenges. The first challenge is that if the same data was retransmitted multiple times, then you can distinguish between those retransmitted data. But still, it brings you some possibility to at least detect spurious retransmission. So, and the other challenge here is that if you get packet which includes data's with and without RBID, it brings some complexity to implementation, because then you need to send back two acknowledgements, one with RBID and the other one without RBID. So the current version is 0.0, and there are a couple of TBDs. The main TBD is state recovery after spurious retransmission detection, so we need to describe it. It's implemented in Ericsson SCTP, but only enabled between Ericsson SCTP endpoints. We have local patch of Linux SCTP, very simple implementation without negotiation. Just started some first interoperability, which is successful. And our plan is to work on TBDs. Hello? So, and continue interoperability with Linux SCTP, and we encourage people to provide feedback on this draft. And if we don't have serious objections, negative feedback, we like to adopt it in the workgroup.
I have a slightly higher bar. I think I want to see that it actually gives benefit to enough people to want to adopt it. So I would like to see some performance and analysis of the results as you go forward, and we can help that to inform the adoption call.
Yeah, okay.
And
Any
thank
questions?
Thank you for presenting. Any questions? I really think the questions can be taken on the list. We're short of time.
Yeah, thank you.
This may come back again, but please read it on the list and please comment on the draft if you're interested in SCTP. This may be a useful feature, or maybe something you want to experiment with, or maybe something you don't want, but please discuss on the list. Do we have any last comments? Thank you ever so much for coming to TSVWG. The next meeting will be at the next IETF. Please use the mailing list. Thank you ever so much. Bye-bye. Thank you. I should say a compliment. I have to run to a lot of questions. Yeah. Maybe we can yeah.